All right, so in today's lesson, we're going to start by just looking a little bit at scientific notation. And why is it helpful to write numbers in different ways? This way of writing a number, like scientific notation, deals with numbers that are really, really big or really, really small. So a lot of times it's numbers that you see in science, and that's partly why we call it scientific notation, because a lot of times when you're measuring or referring to numbers in science, it's things that are really, really tiny or really, really big. So like the planets there, if you were measuring the distance around the planet, that would be a huge, huge number depending on the unit you're using. Or if you were measuring from here to a different planet, something like that. Those are really big numbers, and sometimes it's nice to have a shortcut way of writing them. But we're going to look a little bit more at this shortcut way, this form of this notation, a little bit before we actually get into converting between scientific notation and what we call standard form, which is how we normally write our numbers. So I wanted to do that first a little bit here. So here's a problem where we have a single-sided, single-layer DVD that has a storage capacity of 4.7 gigabytes. So if we were looking at this a little bit differently, 1 gigabyte is equal to 10 to the 9th bytes. So these are different units that help us look at our numbers in different, we'll say sizes, because they have, maybe the numbers are shorter to write if we use a larger unit. But if we're actually wanting to show some sort of expression that represents how many bytes can be stored on the DVD player, or on the DVD, if we were to write a multiplication expression with that, it would look something like this. We would take 4.7 and multiply it by 10 to the 9th. That would tell us what? 4.7 is how many gigabytes we have, and each gigabyte has 10 to the 9th bytes in it. So this would tell us how many total we would have altogether. Now, we haven't actually done the multiplication, but this is just a way to write that in a shorthanded way. Now, if we were to take this a step further and look at this table, that's what I want you to kind of focus on. We're going to look at some patterns and some relationships here between our exponents and our powers of 10. So if I start with this first row, I have 4.7 times 10 to the first power equals 4.7 times 10, right? Because 10 to the first power is just the number 10. So if I were to actually multiply those two numbers, 4.7 times 10, you would get 47. So that's what we're saying as the product. Remember, product is the answer to a multiplication problem. Now, if I go to the next row, you're multiplying by 10 squared. 4.7 times 10 squared would be 4.7 times 100. If I were to multiply 4.7 times 100, now my number is 470. All right, and let's jump over to the other column now. Let's say we now have negative exponents, because in scientific notation, sometimes you have positive exponents, sometimes you have negative exponents. When we're writing these expressions, we can have either. So I wanted to show you the difference and how it looks. 10 to the negative first power, remember when we have a negative exponent, it just means that you put that into the denominator of a fraction under 1, and you would just change your exponent to a positive exponent. So this becomes 10 to the negative first would be 1 over 10 to the positive first, or just 1 over 10. If I were to multiply 4.7 times 1/10, which is the same as 0.1, it would be 0.47 as my product. So you can see my answer there is now a number less than 1. Let's try the next row and see what we come up with. 4.7 times 10 to the negative second. So you can see I'm just, in this case, decreasing my exponents by 1. So now I'm at negative 2. Well, 10 to the negative second is really 1 over 10 to the positive second power. And 1 over 10 to the positive second would be 1 over 100. So 4.7 times 1/100th would give us 0.047. Now I have an even smaller number than what I had when I multiplied by 10 to the negative first power. And then we could keep going. So what I want you to be doing in this lesson is actually to finish this table here, and you're going to look at your pattern. You look at a relationship here, and you're going to focus on what happens when we're multiplying by a positive power of 10 versus a negative power of 10, and how's that relating and changing our decimal, the decimal point. How is it changing the exponent? How is it changing your answer? Any sort of pattern you can see with your exponents and your final product. And think about the difference between the positive exponent and the negative exponent. So we're going to kind of finish up this lesson looking at that. And in the next lesson, we'll take it a step further and look at specific scientific notation and standard form notation and converting between the two.